Hello, basic calculus students. In this video, I will discuss the limit of a function. For reference, I use the teacher's guide for basic calculus of the DepEd. At the end of this presentation, you are expected to illustrate the limit of a function using a table of values and the graph of the function. Introduction. The limits are the backbone of calculus, and calculus is called the mathematics of chains. The study of limits is necessary in studying chains in great detail. The evaluation of a particular limit is what underlies the formulation of derivative in the integral of function. For starters, imagine that you are going to watch a basketball game. When you choose seats, you would want to be as close to the action as possible. You would want to be as close to the players as possible and have the best view of the game, as if you were in the basketball court yourself. Take note that you cannot actually be in the court enjoying the players, but you will be close enough to describe clearly what is happening in the game. I- This is how it is with limits of functions. We will consider functions of a single variable and study the behavior of the function as its variable approaches a particular value, a constant. The variable can only take values very close to the constant, but it cannot equal the constant itself. However, the limit will be able to describe clearly what is happening to the function near the constant. Consider a function f of a single variable x. Consider a constant c which the variable x will approach. C may or may not be in the domain of f. The limit, to be denoted by capital letter L, is the unique real value that f of x will approach as x approaches c. In symbols, we write this as limit of f of x as x approaches c is capital letter L. Now, there are two ways we can determine the limit of a function. One is using the table of values. The other one is the graph. To illustrate, let us consider limit of the quantity 1 plus 3x as x approaches 2. Now, using table of values, let's take a look at the number line. So here is 2. Using the table of values, we will assign values of x from the left of 2. So you can assign here 1, 1.4, 1.7, and so on up to 1.999. So mapapansin nyo, ito ay very close to 2 but not equal to 2. And assigning that values of x, we can solve for the corresponding values of f of x. So as we approach 2 from the left, we can see the value of f of x is approaching 7. After that, uh, we will now consider approaching 2 from its right or through the values greater than but close to 2. So, kung nandito yung 2, pwede natin i-assign 3, 2.5, 2.2, and so on up to 2.0001. So, this is very close to 2 but not equal to 2. So using these values, we can determine the values of f of x. So as we can see, if we approach 2 from its right, the value of f of x is approaching 7. So, tingnan natin, compare natin, pareho silang approaching 7. So, from that, we can say that limit of the quantity 1 plus 3x as x approaches to is 7. Now, let's take a look at the graph of the f of x equals 1 plus 3x. Tingnan natin yung graph. Nandito yung 2. Yung value ng y is 7. So, approaching 2 from the left, you can see value of y is from 4 to 7. Approaching 2 from the right, values of y is from here up to 7. So, parehong value ng f of x ang ina-approach nila, whether we approach 2 from the left or we approach 2 from the right. So from that, we can say limit of the quantity 1 plus 3x as x approaches 2 is 7. Okay, so we have another examples here. Limit of the quantity x squared plus 1 as x approaches negative 1. So using this table, as we approach negative 1 from its left, the value of the f of x is approaching 2. As we approach negative 1 from the right, the value of f of x is also approaching 2. So, since pareho yung value ng f of x na ina-approach nila, both from the left and from the right of negative 1, so we can say limit of the quantity x squared plus 1 as x approaches negative 1 is 2. Okay, another example, investigate the limit of the absolute value of x as x approaches 0. So from the left of 0, we have these values, and here we can see that the value of the absolute value of x is approaching 0. Now from the right of x, as x approaches 0, the value of the absolute value of x is also approaching 0. Now from that, we can say limit of the absolute value of x as x approaches 0 is 1. Is 0 rather. Now, looking at the graph, so as x approaches negative 1 from both the left and from the right, the value of f of x is approaching 2. So this is the limit of the function as x approaches negative 1. Now, as x approaching 0 from the left, the value of f of x is approaching 0. As x approaches 0 from the right, again the value of f of x is approaching 0. So we say the limit of the function as x approaches 0 is 0. Now, let's have this example number 4. This is what we call piecewise function. Now, the principle is the same as the previous example, only that we will consider here the condition for x. If x is less than 4, we will use the f of x equals x plus 1. But if x is 4 or greater than 4, we will use f of x is the quantity x minus 4 squared plus 3. Okay, now let's take a look at the table. As we approach 4 from the left, so we have assigned values 3.7 and so on to 3.9999. The value of f of x is approaching 5. On the other hand, as we approach 4 from the right. So using the values 4.3, 4.1 up to 4.0001, the value of f of x is approaching 3. So tingnan natin ito. Magkaiba yung values ng f of x as we approach 4 from the left and from the right. Pag ganito ang case, sinasabi natin the limit does not exist. So in symbol, we write that limit of f of x as x approaches 4 does not exist. So in symbol, we use capital letters D, N, E. Okay, so let's take a look at the graph of the example 4. As we approach 4 from the left, ito yung values ng f of x natin. So it approaches 5. As we approach 4 from the right, ito yung values ng f of x natin. So it approach 3. So magkaiba yung point na ina-approach nila. So sinasabi natin pag ganito ang case, limit does not exist. Okay. Now, let's take a look at this remark. Number 1. We need to emphasize an important fact. We do not say that limit of f of x as x approaches 4 equals DNA. So, hindi tayo maglalagay ng equals. Nor, hindi rin tayo magsusulat ng equal symbol. Because capital letter D and E or does not exist is not a value. In the previous example, does not exist indicated that the function moves in different directions as its variable approaches C from the left and from the right. In other cases, the limit fails to exist because it is undefined, such as for limit of 1 over x as x approaches 0, which leads to the division of 1 by 0. Remark number 2. Have you noticed a pattern in the way we have been investigating a limit? We have been specifying whether x will approach a value c from the left through values less than c or from the right through values greater than c. This direction may be specified by the limit notation, limit of f of x as x approaches c by adding a certain symbol. So, if x approaches c from the left or through values less than c, then we write limit of f of x as x approaches c with negative sign. Tandaan natin yung negative sign. Ang ine-indicate lang natin ito is kung ina-approach natin yung C from the left or from the right. Pag negative ang nandyan, ibig sabihin, ina-approach natin yung X from the left. Pag positive naman, ina-approach natin yung X from the, or ina-approach natin yung value ng C from the right. Okay. Furthermore, we say that limit of f of x as x approaches c is L if and only if, take note of the condition, if and only if limit of f of x as x approaches c from the left is L and limit of f of x as x approaches c from the right is L. So dapat if we approach c both from left or from the right, pareho yung value ng f of x na ina-approach nila for a limit to exist. For any clarification, you can send me a message or comment. So,